Right, let's look at the electronic configuration of atoms. Remember, when we were looking at the structure of atoms, we said that the atom consists of a central portion called the nucleus, which contains neutrons and protons, and surrounding the nucleus are electrons. Okay, so here we have electrons occupy shells or energy levels. Now, the arrangement of electrons in an atom is called electronic configuration. So the arrangement, how the electrons are arranged in an atom, is what we call electronic configurations. Now, there are certain rules that governs how the electrons are arranged in every particular atoms, and we want to look at the rules and look at some examples in this video. Now, the first rule is that the lower energy levels are filled first. So when you are writing the electronic configuration of an atom, you've got to fill the lower energy levels first, or the lower shells. The first shell is filled before the next shell. Okay, so that's the first rule. The next rule is that each shell can take certain maximum number of electrons, and they cannot exceed that. Okay, so every shell, lower energy level, next energy level, or the highest energy level, can take certain maximum number of electrons, and that cannot be exceeded. Okay, so let's look at the number of electrons that each energy level can take. The first energy level can take 2, the second energy level can take 8, and the third energy level can also take 8. Now, if there are any remaining left, that can go to the next energy level. At this stage, we are looking at the first 20 elements in the periodic table, and so most often than not, we will have 3 shells or 4. Okay, so with that, let's look at example here. We've got sodium, which has atomic number of 11, and so if we want to apply the rules to write the electronic configuration of sodium, we're going to have the first energy level will take 2, next energy level will take 8, 8 plus 2 will be 10, we will be left with 1 because sodium has atomic number of 8, and so the remaining 1 electron goes to the third energy level. Okay, so that's the electronic configuration of sodium atom. Let's go to sodium ion. Now, sodium 1 plus ion means that sodium would have lost 1 electron. Now, if it loses 1 electron, it will be left with 10 electrons, and so the electronic configuration will be 2, 8. The first energy level will take 2, and the next energy level will take the remaining 8. So that will be the electronic configuration of sodium ion and the electronic configuration of sodium atom. Now, you should be able to draw the electronic configuration of sodium ion and atom as well. Now, let's look at lithium. Lithium has atomic number of 3, and so if you write the electronic configuration, the first energy level by the rule will take 2, and the remaining 1 will go to the next energy level. Lithium ion would have lost 1 electron because it's 1 plus ion, and so it will be left with 2, and that 2 goes to the first energy level, or the 2 goes to the first energy level. So that is the electronic configuration of lithium ion and lithium atom. The next one we want to look at is magnesium. Magnesium has 12 electrons. The atomic number of magnesium is 12. Now, since the number of protons is equal to the number of electrons, if the atomic number is 12, it will therefore have 12 electrons. And so we can arrange all the 12 electrons following the rules in this way. The first energy level will take 2, followed by the next energy level, which is supposed to take 8. That adds up to be 10, and we'll be left with 2 electrons, and that goes to the third energy level. So we have 2A2 electronic configuration. Now let's look at the ion of magnesium, which will be 2 plus because magnesium is in group 2, and therefore it's going to lose this here, 2 here, and form 2 plus ion. Now having formed 2 plus ion, it means that it would have lost 2 electrons, and therefore subtract 2 from 10, you'll be left with 12, you'll be left with only 10 electrons, and that can be arranged in a 2-8 manner. Now let's look at calcium. Calcium has atomic number of 20 and therefore it's got 20 electrons. That 20 electrons can be arranged in a 2-8-8-2 format. Okay, and so if we look at the ion of calcium, calcium would have lost 2 electrons in its outer shell because calcium is in group 2, and therefore will be left with 18, and therefore the 18 will be arranged in what 2-8-8 format. And this can also be drawn if you are required to draw the electronic configuration of an atom or an ion. You should be able to do that if you understand the whole principle of ion. Now, having lost 2 electrons as calcium 2 plus, it will be left with 18, and that can be arranged. The first energy level or the first shell take 2, the next shell take 8, and the last shell take the remaining 8. So that's how we arrange electrons in an atom or an ion. An ion would have lost or gained an electron, and an atom can be arranged following the format. Hope this helped.